Welcome back to the Aspen Plus video tutorials. This is part 3, and in this part I will be going over more of the unit operations, and we will be looking in depth at the distillation columns. So I've gone ahead and set up a new simulation with an hexane and an decane, just to go over one of the distillation examples that is from Aspen Plus in 24 hours. So to start off, we have our stream, and we will look at the pressure changers. So we have our pumps and our compressors. So we'll add a pump here. And similar to what we said before in previous videos, we can see which values we need to input based on whether or not the red circle is still around. So under specifications here. So let's say our pump efficiency is at 85%. And we need to specify one of the following, either the output pressure, the pressure increase, the pressure ratio, or the power of the pump. So let's set the output pressure to 5 atm in this case, and then we have our check mark and everything is specified. Returning to our main flow sheet, we can now look at the distillation columns. Aspen Plus has several types of distillation columns. We have the first one here, which is the Wynne-Underwood-Gilens model, and it uses a lot of assumptions and it has a lot of shortcuts. This one is also another shortcut model. This is the one that we will be using today, which is the rigorous model, and it has a wide range of operations. The multi-column here is basically a collection of multiple of this rigorous rad column in a row, and then this one here is basically a shortcut version of the multi-column. So the one we'll be going over is just the rad frac. Aspen Plus in 24 hours, the tutorial which I'm using as an example for this, has a little summary of each one of the columns and some details about them as well. So placing the column here, we'll notice that we do have our reboiler and the condenser here. And we can see our condenser and reboiler, even if I specify them as none, when I return to the main flow sheet, they will still be here. So if you want the ability just to remove them from visibility, if you only have a condenser, if you only have a reboiler, you can click on the arrow and then pick a different, just a different model here. All of the specifications will be the same, no matter what you input. It's just what you visually see to better understand. So let's delete this one for now, and we will input here. So for this one here, we will be using a total condenser as well as a kettle reboiler. And I will just be taking the specific numbers from the tutorial that I am using as an example here. Like so. And we'll have 15 stages for this column. And we must also put our output stream. So let's add our output streams as well. We'll have an output stream at the bottom as well as one at the top, like so. Returning to the internals, we can then set at which stages our streams will be inputting and outputting. So for stage number, our input stream, number S3, we'll input it at stage number 3. And we'll have it as an above stage, but we can also change the convention to on stage, a vapor or liquid. Our outputs will be stage 1 and 15. And then we can specify the pressure as well, which we will have as 5. There we go. And then there are also options for looking at your condenser and reboiler. Similar to Aspen HYSYS, you do have the reboiler wizard that you can go in and specify more in detail, but I'll leave it as is. So running the simulation here, and then we can check our results as normal. And let's look at the mole flows, and we can see the mole flows of each one, our input, our output, and how they are extracted from each other via the distillation column. We do have a little bit of our hexane in output S3 as well, so it's not 100% separation in this case, and S3 is our top feed here. So going a little bit more into detail about the actual distillation column, we can go under blocks, and then looking at the distillation column, I didn't name it, it's just B2 here. We can look at the different profiles to see what happens exactly inside the column. So at the top here, we can look at temperature, composition, flow rates. Let's start with temperature here. We can see the temperature of the column at each stage, and we can switch that to look at the composition. Going back here, we can see the composition of N-hexane and N-decane, like so. And let's keep it in moles for now and only look at the liquid. And we can see their composition. Their mole fractions, depending on which stage. And we'll recall that stage 1 is the top and stage 15 is the bottom. Next, we can go under specifications once more. And let's design and specify the column internals. We'll generate the missing data required. Then from here, you can see what the inside of the column looks like. You have an option to automatically add column internals based on the feed or based on the flows, but for now, let's just add one manually. And we can set where we want our column internals to start and where we want them to end. So let's end at, let's say, stage 10. So here we have my column internals from stage 1 to 10, and then we can add another one from stage 10 to 15. That is overlapping, so I actually want stage 11. There we go. And it does show us which one is which based on the color. So from there, we can look more into how we want our column to be designed. Is it a tray or is it a pack type? And what kind of packing or what kind of trays do we want? So we have a whole bunch of different ones that Aspen comes pre-programmed with, and you can also select a custom one if needed. So let's leave it at the default for now. And with the packed, we can also specify the details of the packing. So we have a generic vendor, or Aspen Plus also puts in different companies that it has in its database. And we can specify the material of the packing as well as its dimensions. To go into more details, we can also click View here, and we can go into even more details about this specific pack tray. So we can change the section here, start stage, end stage, our mode, and is it packed or is it trade. So if we change it back to trade, for example, we can then see the different types of trays in more detail that we had before. So clicking on this one, see this is the different types of trays, and then you can specify very specific dimensions for each section of your column based on your calculations. And we can add a custom one. So we need rating mode to add custom trays. And from there, we can have the opening as well as our specific configurations that we want. Now that we've looked at distillation columns, I also want to highlight that Aspen Plus can actually create vapor-liquid equilibrium diagrams, which help us better understand how chemicals need to be separated and how to better define our distillation columns and its stages. Going back to the Properties tab, we can go under Analysis. In the top menu, we can then click Binary for the liquid vapor equilibrium diagrams. So first we'll pick a temperature XY diagram at a given pressure. And we also have the ability to specify whether we want a range of pressures or specific pressures to be shown to us. So in this case, let's put a pressure of 1 bar, 5 bar, and 10 bar here. And then we will pick what our components will be. For this example, I will be using methanol and chloroform, which is, I believe, tutorial 2 in Learn Aspen in 24 hours. And we can also look at which phase we want to observe. So that will be under calculation options, and we can see the valid phase, and we'll be selecting vapor liquid. I believe that in Aspen version 12, the flash option where you pick your valid phase was actually under binary analysis and not calculation option. So that is one thing to consider if you are looking at any tutorials for version 12 or below. Next, we need to make sure to select the correct property method, and you'll notice that not every single property method here is an option. The ones selected there are only the ones that I have calculated the binary constant for. So if we return to the methods and switch our method to Penn Robinson, and we recalculate our binary methods, and returning to the analysis, we can now notice that Penn Robinson is now an option since the binary coefficients and parameters have been calculated by Aspen Plus automatically. So selecting the property method we want and selecting true components, we can then run the analysis, and we obtain the vapor-liquid equilibrium diagram for a variety of temperatures at the given pressures that we specified. While we are still in the Properties tab, I want to highlight one more thing. If you go under the top menu and click on Retrieve Parameters, you will find all of the parameters that Aspen Plus uses for the simulation for each specific component. As you can see here, we have all of the parameters. We have, for example, the freezing point, we have the molecular weight of the compounds, we have the critical temperature, critical pressure as well. And while some of these might not be obvious what they are, there are Aspen user guides to help better understand what all of these acronyms mean. Going back to our simulation tab here, we'll run the simulation once more before adding anything to make sure that we don't get any errors. Let's look at manipulators. So the main block I want to highlight in manipulators is the transfer block here. And this block will allow you to transfer values from one stream onto another, which is very useful when looking at recycling streams. How Aspen Plus does recycling is you will need some kind of tear stream where you specify a value to start off with, and Aspen Plus will then, based on that value, do multiple iterations of the simulation to see what that stream will actually end up being. So let's set a stream here. We'll call it 100% hexane. And then we can copy paste the stream downwards. We'll just change the ID to S2. Oh, we have an S2 already. S8, I think. Number 8. Yes. Okay. And for this one, we'll change it from hexane to methanol. So we have our two streams here. And the transfer block doesn't actually need anything to be inputted into it. We will specify what the input and output is based on the specifications of the transfer block itself. So let's input stream number 8, which we specified, and we will copy that stream value over to stream S6. Or sorry, S3. And we can copy it over to multiple streams if needed as well. So just to remind ourselves, S3 we had fully hexane, and stream 8 we had it fully methanol. But we specified that we want the value of stream 8 to be transferred over to S3. Looking at the transfer block, we also need to specify the sequence. So you can either have it do the transfer first thing, right as you're beginning the execution. You can have it before a certain block is executed, after a certain block is executed, or you can have it occur all the way at the end. So we'll do first for now. And then we can look at the results of S6, which was our output that we copied over. And we should find that it is now all methanol, which is not what we had specified since the transfer block overrode it, as you can see here. So this is excellent for when you need to have recycling streams. You can have some value that you don't know right away on your input stream, such as S6, which is used in the recycling, and then use the transfer block to input the specific values that you need. The transfer block also helps because you can specify when you want it to do the sequencing and when you want to copy over. It does help avoid some errors instead of just copying the same stream over into whatever stream you needed to recycle, whatever block, you needed to recycle into. And that's all of the unit operations I will be going into detail for these tutorials. All the other ones here are very straightforward, where if you have a value missing, it'll always tell you you are missing something based on the red circle, both here and it'll tell you here as well. So just looking over some of them, you have the multiplier one that will allow you to multiply streams. You have duplicating streams as well. For solids and solid separators, you have crushers, you have granulators as well. So different unit operations for solids. And for solid separation, you have different types of solid separation. You have solid gas separation, such as the cyclone. You have solid liquid separation, such as the centrifuge filters, or just regular filters as well. So each of these unit operations, you'll always know what you need to specify based on if you have any red circles on the side here, and you'll know that everything is specified once all of the circles disappear. The next feature we will be going over is the utilities. Utilities can be found here in the sidebar, and utilities is one of the things that I personally struggled with a lot and encountered many errors. So just go slowly and take your time. So first, let's add a new utility. So we can define what we want our utility to be. So we can have it be different types of streams. We can have it be cooling water, air, different refrigerants, or we can make a custom one if needed as well. So for now, we can add electricity as a utility. And Aspen Plus has specific values, but if based on where your simulation, like the plant that you're simulating occurs, you can change the prices, the purchase prices. Aspen Plus also offers carbon tracking for the utilities based on different emission data sources here, and you can change whether it'll be a scope 1 or a scope 2 carbon emission. So going back, let's add a couple more utilities. Also make sure to name them correctly so that when you're using them in your simulation, you know what they are as well. So very high temperature, we can name it high temperature, like so. And for the temperature ones, you can add the energy price as well as our inlet and outlet temperatures and what the heating or cooling value will be. So if you have a specific like refrigerant that you're using for your simulation, you can also specify that. So we can do refrigerant 1 down here. And then again, you can specify the inlet temperature as well as the outlet temperature. So all of the utilities that we have added here does not necessarily mean that we will be using all of these. So to specify utilities, we're in our flow sheet. We can click on our unit. And some of them have a utilities tab like so, or we can specify. So for example, for the pump, we can use electricity, which here is our electrical utility, which I forgot to name. But if you hover over them, it will tell you what they are, as well as any inlet or outlet pressures that you have. So let's say our pump is based on electricity. And some of the units do not have a utility tab. You might need to specify the utility under some subs tab. So the distillation column, for example, you have utility under the reboiler, as well as a utility under the condenser, but there's no utility under the actual configuration of the distillation column here. And there's no utility tab, since there are two different ones that you need to specify in this case. So if we run that, we will now have some carbon emissions here based on the fact that we specified electricity as our utility for this, and this is the carbon emissions in relation to that, which we can remember if we go back down to utilities here. Under the electricity one, we are using the US one, and we specified it as a scope 2. If I change it to a scope 1, which it's not in this case, but just to see the difference, it will just move right up there. So adding all of your utilities to all your units, I would definitely add them one at a time and run your simulation in between each one. You might have issues with temperature crosses if the temperature change in the utility is not enough to run your cooling or your heating that is needed for your unit. So just going through slowly for the utility one by one and making sure everything's correct is what I would suggest. Finally, for this tutorial, I want to go over the economics as well as the possible energy savings. So let's turn those on. So here we have our capital cost as well as our utility cost based on these two units here. We can click on economics to go into more details as to where the cost is coming from. And all of this is in USD in this case. And we can see different unit operations and what their equipment costs as well as what the installed cost and the utilities cost too. And the utilities cost is once again based on what we set as the cost to be, cost per hour, and the cost of utilities. If we go back to utilities once more, here, specifications, here we have the cost. So let's change this one here. Let's up it. Let's just say 0.1. Let's up it to a very high amount and run that. Our utility cost changes completely here. It is important to note that these values here are just estimates based on what Aspen Plus has in its database. They're good to use for comparison, but it's important to always look over your own capital costs and OpEx costs based on your equipment sizing. Some of these equipments might not be sized in Aspen Plus correctly. And finally, we will be looking at the energy. So this is once more just a tool. You'll still need to go in and determine where your energy saving where you might be able to save energy based on your knowledge from different classes. So let's add a cooler, for example. We'll just add one here so that we can see what the energy savings might be. Like so. Okay. And let's cool down to 25 Celsius. And let's say 1 ATM. Running the simulation, all of our values will be recalculated. And now we do have some energy savings since we have the cooler as well as the condenser and reboiler. Looking at the energy, we can see where we can have energy saving based on different design changes and different configurations. So it'll tell us we might be able to add, like here are all of the heat exchangers, here are all of our utilities, and we can find design changes where it says that we might not be able to modify anything, but we might be able to add a new exchanger. This is, once again, just a tool. You do still need to go in with separate analysis and see what is best for your specific simulation. This is just a good starting point. Same with the economics. It's a good starting point or a good before you go in and do all the working calculations that you need to do. So that is it for the Aspen Plus tutorials. If you guys require any more information or any practice, like I said multiple times, Learn Aspen Plus in 24 Hours is a great resource. It's how I learned everything for Aspen, and I wish you guys luck with your design projects.